In number 2, you need to be able to visualize the molecules in 3 dimensions in order to determine whether they are polar. Alright, so for the first molecule, this is a trigonal bipyramidal molecule. I have drawn it in the 3-dimensional representation, and based on this, the bromines, they will cancel each other out because they are directly across from each other. However, it's a little more difficult to see the fluorines. What they look like if we rotate this molecule is this. The fluorines actually form a trigonal plane around the phosphorus. And since these are all equal and they are all equally distributed, they will cancel each other out. Therefore, this is a non-polar molecule. Okay? Now, if we change the positions of the bromines, now the bromines are not directly across from each other, so they do not cancel each other out. And the fluorines are not symmetrically distributed. They are not directly across from each other, so they do not cancel each other out. Therefore, this is a polar molecule. Alright, and the last one, this is an octahedral structure, so we have a square plane around the middle, and then we have an ammonia out the top and a fluorine around the bottom. Now this could be rotated to show some other structure. Now, let me erase this so that we can see some other stuff here. Alright. The fluorines are in the back. Alright. So they're sort of making they will work together to go out the back of the molecule. Now imagine this being angled down behind the phosphorus. And the ammonias will pull out towards you from the screen. So they are in opposite directions, but they are not equal. The 3 ammonias are not equal to the fluorines. Therefore, they will not cancel each other out. So this is a polar molecule. So, and it should be circled.